Hmm. All right. So most people don't log in online too.
Okay. Good morning,
Hello.
Professor.
No, speaking to the ones online.
I was saying good morning, Professor.
Yeah, good morning. How y'all doing? All right. Anybody with any questions about the program? Questions?
Hey, I don't know if I should wait till the end to ask you. It's about something I was trying to do for the bonus points.
What's that?
Well, in the first one, I did everything with array plus plus,
Correct.
except my sorting function. For some reason, I couldn't do it that way. So I had to use for the sorting function, I had to use
Right. You can use
the
any type of
notation of the
pointer.
other one.
Yeah, you can use any type of pointer manipulation you want to, long as you're using pointer.
Okay,
Right. You could
okay,
even create a pointer variable. And you know, when you do your swap, you do all that stuff. It doesn't matter.
okay,
Right.
okay.
As long as you use the pointer manipulation. All right. See this thing here? I'm glad I didn't go. Let's see. All right. So if there's no question, let me share my screen here. And those in the class, I guess you could go to the stream. You can hear me in the classroom. And I don't think this thing is there. Start visual. Take a few minutes. So yeah, we'll do that over here. Okay, share my full screen. All right, so let's get to the notes. So we looked at pointers and looked at the notes on last class period. Okay, and like I said, hopefully everybody kind of got a gist of what pointers are. And like I said, I just picked out a particular way to manipulate pointers for you to use in your program. All right. Now, so like I said, we went through all this on last class period. So if we go back to our canvas, all right, I have, this will be chapter 9. Test there, chapter 9. I have the test set up for, I think yeah. Well, yeah, the test is set up for, I guess you start the test on the 20th and complete it on the 26th. Okay, so we kind of somewhat getting back on track. All right, so you got time to, I guess, finish your programs tonight and tomorrow. And then after that, you have that on the 20th, you have that week to complete the test. All right. Now, chapter 10, all right, you have some reading material, but let's go to the notes. This dealing with characters, strings, and the string class, all right? Okay, so character testing, all right? The C++ library provides functions for testing characters, all right? So what that means is a given character, whether it's a char variable or a char value in an array, you can check to see if that value or if it's a number, if it's a special character, if it's a non-printable character, if it's an uppercase letter, if it's a lowercase letter, you know, different things you can test for. So if you look at this, this shows you, this sample code here shows you how you can declare a variable to be of char, which is a single character in what? Single quotes. And you can check to see if letter by using what? This particular function that's already written is upper to see if that character or letter, whatever value stored in letter, is a uppercase letter. All right. If it is, it would they say is upper. Is it upper? No. So it'll do the false. So it would not output letter is upper, it do the false. Now, the thing is this, you can test to see if the letter is upper or lower, even if it's an exclamation point, a period, a special character, or whatever. The only thing is, it'll just return a false, result. All right. So if it's not a character at all, you understand? Well, alphabet at all, then it'll default to no. You understand? So if it's uppercase, no, it's not, then it's gonna do the false. So here are some of, if you look at this little table here, this is just some of the different functions that can be used. Is alpha. Now alpha means it's only what? Only letters, right? Yes, sir. Can I think I can, cause what I could do, I could control them both at the same time. Right, man. Well, I left my other the laptop with the connect dongle at home, so I can't connect, but not at home, but back home. So let me turn this on. But if you go to the stream, you would see it. Let's see. So what's on for PC? Chrome up here. Give me a second, Clown. Yes, ma'am. I'm in class. What's up? What you got? Oh, for the 12 week? Yeah, just do by tomorrow. Right. Okay. Yeah, because I don't have people come in and do something already. All right. All right. So let me go here. ST-lab 206, and then all lowercase, BRCC. It's ST dash. Yeah. All right. So class, okay, here's what we are here. Why is this? Okay. Man, what's this screen? I'll tell you, I ain't got time to fix it right now. All right. So here's what we're looking at, class, on the stream. We're looking at this information here. So if we asking if something is alpha, we want to know if it's alphabetic, if it's any one of the letters A through Z, right? Uppercase or lowercase. Everybody got that? Then we could ask if it's alnum, which is alphanumeric. So alphanumeric would be what? Letters and
Numbers.
Numbers, correct. Now, what would be the advantage when you're checking something to be alphanumeric? What data entry field is alphanumeric in general?
A password, a library classification.
and more general, your address, right?
Oh, right, right.
Right. You know, normally address is a street number with a name, correct? Right. So I'm just saying those are some of the alpha, like I say, alphanumeric fields, right? But this here will check only each individual character, right? Not like if you're in a database and you ask if that field is that whole field is alphanumeric. So you can check to see if something is a digit, all right? So if we had a like the letter A, and we ask if is digit, it would be false. It would return false because a letter is not a what? A digit. So see how we can write code based on these functions to manipulate what? Character data. All right. Is lower. That's if a character, if a alphabet is lowercase. Is print. Is print. That that checks to see if a character is a printable character, because we know some characters are non-printable. What are some non-printable characters? What about \0, which is our null terminator? You can't print that, but it is a character, you know, that's a character. \T, you can't actually print it, it's a character. You got what I'm saying? So you got non-printable characters. End of file, non-printable character, right? Marker. Then you got is punctuation. So you know, commas, your periods, etc. Right? So all those different things. Then you got is upper, but also now you have is space. So now you can check to see what if something is a space. All right. So you have these functions that can assist you in manipulating your data. All right. Now, here's a small program. If you know, look at this slide here. Just a small program, but look what they had to do first. They had to load what? They had to load the what? The CC type what? Library. Okay. Everybody understand that? They had to load that library in order to use what? Those functions. Otherwise, the program would give you errors. Okay? You gotta understand it. Just like using vectors, you gotta load what? The vector header, header file or library file. So if you look in here, what they're doing, they not now, and I'm gonna show you something. Look at this statement here. You may or may not have had issues prior to this dealing with CN, right? Look at this statement, cn.get, right? What's gonna happen here, when you start reading in numbers, then characters, and back to numbers, you will find that your program will all of a sudden start skipping an input. It'll just take input that's already in the keyboard buffer. So what happens is, and you have to know your program, go through your program. When it reads in a number, it's fine. All right. How would I say it? Well, you're reading a char data, it's fine. You read up until maybe the end of line, etc. But then when you read in that number, when you do a CN in that number, is it the number? You're reading that number, it's gonna take just the number, but it's gonna have the like the end of that input, like the return. And what it's gonna do is gonna take that and say, okay, well, I have something freed up still in the buffer, and it's gonna take that and try to store that in that next input. So you're gonna have to start using the cn.ignore. All right. And like I say, I don't know if we did cover it, I think in 193, but then in 194, you're gonna see that you're gonna be heavily using it, because when you're going back and forth between entering character data and numeric data. All right. So you got cn.get and what? They reading in a char of variable, all right, a value, all right? They reading in whatever that character is, all right? So it says the character you entered, so they just outputting it. But now what? If it's alpha, you're gonna output this. If it's a digit, you output this. If it's lowercase, you output this. If it's uppercase, you outputting this. If it's a space, you outputting this. You understand? So, and notice this if statement is not like it's not a nested if, because what? Once it checks it, it finishes that if and it's gonna ask each individual question, right? Because what? A character could be alpha and it could be alphanumeric, right? And it can be uppercase, correct? So it can have multiple characteristics depending. All right. So this is just a little small program. You probably could type it in and check it out, see how it works for you or not. All right. Now, here's a little program that somewhat shows you, kind of get your feet wet with kind of understanding how passwords work, or maybe how how do I say it, formatted data work. Like say if you gotta input like a L number for BRCC, the first character is what? If you with your L number, the first character in your L number is what? The type. It's alpha, and it's what? No, it's alpha and it's uppercase. Because if you try to put lowercase anytime, it'll say incorrect, right? So it's alpha and it's uppercase. So if I gave you a program to actually test to see if an L number is valid, now you can't tell, you can't check the range of the number, right? But you can check to see if the first position is uppercase and what? They normally use all L's. If it's L, right? And it's uppercase, but then check to see if all the other positions of that input is what? Digit. You understand? So what? A letter, an uppercase letter, and what? X number of digits, correct? Because if I have a digit anywhere, I mean a letter anywhere in that L number, it's what? It's wrong. If I have a dash, a special character anywhere in that L number, it's what? It's wrong, right? If I even have a comma anywhere, it's wrong. So you see what I'm saying? How you can test to see if a L number that's inputted has the proper what? Format. Then you could what? Actually say, okay, one letter, okay, check to see if the first position is a letter, and then X number of characters is numbers. All right. So you can count to see how many of those are numbers. So there's many different ways you could check and validate something, using code. So if we look at this one, all right, I'll make this one a little bit bigger. People can see. I don't know why this is like this. All right. So if we look at this, all right. All right, so we look at this, what they did, they got IO stream, because what? They're inputting and outputting. They got the what? The CC type library, because they're going to use what? Some of those functions where we see what? We see where's the function here? Oh, on this side. You see if alpha and then is digit. You got me? So what happens is they have an array set of named customer, size 8, okay? Now, so what happens is they ask the user to input 8 characters. Now, but I think they also gave them the format L, 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 and then N, 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 all right? So what happens is the first 3, all right, should be letter, 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 all right? And then what? Number, 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 number. So that's just giving the user an idea of what to type in. Anything outside of that would be invalid, correct? So if we look at this, then what they did, they said if test number, customer, size. So what happens is now they're checking to see if what, if it is a valid to the size. So if the size that was inputted it was correct, then it was okay. All right. The size of it. All right. But if we go back here, now they testing for the character part. So they have a loop that goes from 0 to less than 3. So we look at this 0, 1, 2. They checking those first 3 positions to see if it's a what? Alpha. I'm not, yeah, it's alpha. So 3 times they're gonna check here to see if it's alpha. If all of them are alpha, hey, the test is good. There's no false return. All right. But if a false is returned, that means what? Automatically what? It doesn't fail. But then after check the first 3 characters, then it's gonna start from the 3rd character to 1 less than the size. Remember, because the size is 8, but there's only 7 positions. When you're dealing with character array data, you got to remember you don't deal with the actual size. It's always what? 1 less than. You got me? Because what? The computer starts at 0. You remember that? So 0 to 7 is 8. So we did what? From 0 to 2, all right? 0 less than 3 to check the first 3 positions. Then we're going to start at 3 and go to size -1 to check to see if the remaining positions are what? Or integers, or numbers. And if that does not return a false, then your program, not the input is not to say that the input is correct, right? But the input is correct, but may not be a valid entry that's found in the database. Because if you have to go search, then you have to do a search to see if you can find that value in the database. Everybody got it? We did a sort and search, right? Where we typed in numbers, but this would just be a added part to where if it was a certain format you had to type in to search for, you would do this part before you do your search, right? Make sure it's valid, a valid format, and then what? Do a search, all right? All right, any questions? So everybody kind of see what's going on here, all right? So now, this here, what you can do is just telling you can, like say, I can output a lowercase a as an uppercase a if I choose to. Or, when you write a program and you ask, do you want to continue? And you tell them to type Y, right? Now, if sometimes when you're doing a check, you might just check for what? A lowercase y, correct? And or it can say you might have to do if lowercase y or uppercase y. Well, what you can do, you can use that to upper function or either to lower function and say if to upper the letter, the parentheses letter equals y. So whether it's a y, whether it's uppercase or lowercase, it'll check it and move on, rather than you have to check to see if it's lowercase or uppercase. You took the value, you put it as uppercase, and then checked it, and then you moved on, all right? Or lowercase, if you choose to make it lowercase, take the value, they input it, check if it's check the lowercase value. If it's valid, then move on, all right? So those are some of the techniques you can use when you're dealing with these functions, all right? So it said the C++ library provide 2 functions to upper and to lower. Let me get this out of the way. Deal with these 2 screens. And this is where I was. All right, to upper and to lower, all right, for converting the case of a character. These functions are also prototyped in the header file CC type. So be sure to include what? #include CC type. So look here, look an example here of what happens when they just want to output whatever that character is, but they want to output it as uppercase. So it's like C out and then to upper the letter A, lowercase a in single quotes. It's just like saying C out A, in single quotes and stop it. All right. So what happens? It says, okay, I see this this character here. It's alpha. Its uppercase value is what? Capital A. Now, if I would do that on, if I would change this A to like a percent sign, what would be the output? Class? If I would say C out to upper and in single quotes a percent sign, semicolon, what would be the output? Right, because it's not a character, there's no uppercase value for it, so it's just gonna return that value that's in there. So if it's not an alphabet, it's just gonna give you what was there. All right. So it doesn't do any kind of conversion. All right. So at the bottom it says if the argument is already uppercase letter to upper returns unchanged. Any non-letter argument, all right, passed to upper is returned as it is, which we just said that it doesn't change. A percent sign, it's just gonna return the percent sign. All right. So look at this. In this example here, C out to upper asterisk. Just gonna give you the asterisk. C out to upper ampersand. Just give you the ampersand. There's no uppercase value or lowercase value for it. All right. And the percent sign, same thing. All right. To upper and to lower do not actually cause the character argument to change. All right. Or change the stored value. They simply return the upper or lower or equivalent of the argument. Now that's very important because it's kind of like assignment statement. This does not assign or change the value at that memory location. It just says, okay, what is at that location? Okay, display it as uppercase. You got what I'm saying? So it does not change the value that's stored there. Okay, you would have to physically say, okay, like letter is equal to upper A. Now you're doing what? Making letter equal to an uppercase A, because you assign the value, right? But when you just asking a question, like in the if statement, if to upper letter equals A, you're not changing anything. Or C out to upper letter and it's A, you're not changing the value that's stored there. Okay, only if you assign the value to that variable. All right, so if we look here, char letter equal to A, C out to upper letter, and it's gonna output what? An uppercase letter, but really we see out, to lower, really, my fault, to lower. So it's gonna print out a lowercase a at this C out point, correct? But it never changed what letter was equal to, right? It just took it and output it as uppercase. But then if we see out letter, you'd see that it'll print out the uppercase letter. So we forced it to print out a lowercase a, you got me? But then we didn't change it in this memory location. So when we printed the actual memory location, it gave us the actual value. Okay? Everybody see that? All right. Now, here we go. This is a sample program, all right? And notice in here you have your CC type, right? Everybody see that? So what happens here in this program, all right? Remember what I said about you asking, do you want to continue? Yes or no, or whatever. Or while X is not equal no or N, do whatever. So rather than ask whether something is uppercase or lowercase, if you notice right, they're asking while to upper, go again, which is our variable that we read in. Look, it said, if you want to calculate another, what that is, dealing with area of a circle. If you wanted to calculate another area of a circle, then when you get to the end of it, it's gonna ask, calculate another, yes or no. And then you're gonna see in the value into go again, but then what? It's gonna say while go again is not equal to Y, right? Because what? If it's not equal to Y, it's doing this. Please type what? Wait, if it's not equal to Y or N, my fault. So it's forcing you to put in a what? A Y or N, but you don't have to know whether it's uppercase or lowercase. okay? So if you put in the number 1, it'll stay here and say, please type in yes or no. You stay here, please type, well, not yes or no, while in. It'll stay here, please type while in. But if you look at the bottom, you will only perform this do while when what? When to upper, go again is Y. Okay. So if you put in the Y, it'll start this do all over again. And we know that a do allows you to what? Perform statements first and then test. Okay. So that's why you didn't have to ask if you wanted to perform any calculations. This program was executed to perform some kind of task. It went through it. Once it went through it, it asked you if you wanted to perform it again. All right, right here. If you wanted to perform it again. But at this point, they put you in a loop, a continuous loop until you typed in what? Y or N. So you stayed in that loop. You could type 1, 2, 3, 4, X, Y, Z, whatever. Not Y, excuse me. X, Z, Q. It'll just stay in this loop because what? It'll say, you didn't type in a Y or N. Once you type either a Y, if you type in the N, it will automatically end. If you type in the Y, whether it's uppercase or lowercase, it'll say, okay, go back and start again with the do. All right. So now we didn't go through the logic itself, right? But the logic, you should understand the logic. All it's doing is allowing you to input a radius, all right, and then performing the area of a that's I think a circle, right? The area of a circle. Okay. Any questions so far dealing with CC type, the different functions, etc. All right. So you got a lot of programs here, and these programs come out the book, and there's other programs you can look at that allows you to understand how to use those character functions. All right. So now let's look at this. Strings in a generic term that describes any consecutive sequence of characters. All right. So a string in generic terms is just a series of characters, right? A word is a string. A sentence is a string. Your name is a string, right? The title of a song, a book, etc. is a string, a series of characters, right? Whether they got spaces in it or not, right? It's a string. So a string may be constant or variable in nature and may be stored in a variety of ways. Now, C string describes a string whose characters are stored in consecutive memory locations, all right? And are allowed or are followed by the null or character. That's that null terminator. The reason the null terminator is there so that the compiler will know what, where to stop. Because when I print out a string, all I just say is what? If I did string name equals BRCC, in order for the system to know when I say see out name, in order for the compiler to know when to stop printing, it has to have a null terminator at the end of that string. So if I say when I do name equals BRCC and then do see out name, it knows, okay, I'm starting at the beginning address and I'm gonna print every character until I reach the what? Null terminator. Okay, so that's the importance of that null terminator. All right. Now, so it says that the null terminator marks the end of the C string. All right. Without it, a function has no way of knowing the length of the C string. And what it'll do, it'll just keep printing and start printing in other addresses, memory address locations, and giving you garbage. And you're like, well, Mr. Russell, I don't know what my program doing. It's printing funny characters, funny faces, and whatever. Because it's just grabbing data that's somewhere on your system, on your computer, but consecutive to that string array. All right. So that's why the null terminator is very important. Now, if you look at it, a string literal or a string constant is enclosed in a set of double quotes. When I said C out BRCC or name equal BRCC, string name equal BRCC. It have to be in double quotes. So what? The system will automatically place the null terminator for you. Like, no, that was my 193 class. But when you initialize a value, or you just say name is equal to Baton Rouge, it would automatically put the null terminator. You don't have to try to put the null terminator. But if you trying to create a string, in a sense, using a char array, an array of characters, then you trying to initialize it, you would have to put the null terminator. You'd have to tell the system, hey, each character and then the null terminator. All right, watch. So where are we here? All right. So it say let's just all of the program string literals are stored in memory as C strings with a null terminator automatically appended, which we just said. All right. So now, looking at is another sample program. Let's look at this sample program. So, and what they're trying to show you is what I was saying. When you got this, C out this string and it's in double quotes, the null terminator is automatically placed. C out C++ programming is great fun, exclamation point, close double quotes. The null terminator is automatically placed. C out, do you want to see the message again? Null terminator is automatically added to the end. So it says, although the strings are not stored in arrays, they are still part of the program's data. The first string occupies 30 bytes of memory, and the second, which is the second array, or string array, occupies 39. Both sizes include the what? The null terminator. Because if you would exclude it by doing something, copying it or taking it and doing something, and you exclude the null terminator, then you run into problems. You will run into issues. Okay. Now, so let's look somewhat at how data is actually pretty much stored. So when you said C out or whatever, or you created that string, C++ programming is great fun. This is how it actually labeled it or stored it in the computer. The actual string followed by the what? Null terminator. And that, what was the purpose of that? To know when to stop print, right? So that the system will know where the end of that string is. And the same thing for, do you want to see the message again? All right, and space and the null terminator. All right, and like I say, the space was included here, and then the null terminator, because what? You wanted the space between the actual input that the person inputted in the computer. So that's why you see that space there. So it says that it is important to realize that a string literal has its own storage location, just like a variable or an array. When a string literal appears in a statement, it's actually its memory address that C++ uses. So all of a sudden now we're dealing with what? Addresses, like we're dealing with pointers. It says, okay, I don't care what's in it. I don't need to know where, how, the middle of it, whatever. Starting point, because I'm gonna start printing from here and stopping at the null terminator. You understand? But you can manipulate it where you can move, migrate through it, or start whatever. But it worry about the beginning, and then from there the programmer can do whatever and the end. All right. So it says, see how, do you want to see this message again? Question mark space. In this statement, the memory address is the string literal. Do you want to see this message again? Okay. is passed to the cout object. Cout displays the consecutive characters found in this address and stop displaying characters when the null terminator is encountered. All right, everybody got that? Now I'm gonna tell you this, and I'm telling you this for a reason. When I tell you to, well, one of your programs, you're gonna have to take your name, okay? Take your name and start manipulating the name. And I want you to do it without using other, how would I say it? Other advanced functions. I just want you to use the basic string functions we talked about, because there's some other functions that can automatically do some swapping and whatever. But I want you to program it. And what happens is the program I give normally tells you to type in a name, your name, first and last name, in one string, okay? Type your first and last name in one string. Take your last name, store it in a new string, comma, space, oh no, scratch that. Yeah, comma, space. Then in double quotes, put your nickname, which was entered, at some point. Put in your nickname in all caps within double quotes, and then your last name. So now you got to remember what? Hey, if I overwrite my what? Null terminator, then when I start printing out that string, it's gonna just start giving me garbage. You understand? So you're gonna have to either put that null terminator where you need it be, because you might give a size or array size, all right, and then start filling up that array, but then put the null terminator at the very end or whatnot. All right. So, but we'll get to that later. But I just want to kind of put that on your mind, because you're gonna have to kind of be aware of that null terminator. Even testing the data, okay, how do I take the last name and put first into a new string? All right. I have to know where the last name begins, right? I have to know where the first name begins and where the first name ends. So just thinking out loud, if I had a string with a first and last name in it, the first name will begin where? Where would the first name begin? I had a string that I put in my first and last name. Where would the first name begin at? At the beginning of the string, right? Remember at the beginning of that address, correct? Well, that's why the beginning of my name, where's the end of my first name? How can I determine where my first name ends? No, because I got first name, last name. So what determines the end of my first name? Space. You understand what I'm saying? So you look when you're reading, if you see a name, what determines the end? That's space. So now you done found what? The beginning address, and then you can count to know or read and do whatever till you get to that space. And now you know the length or whatever, you done captured each character for the name, for the first name. Now, what determines the beginning of the last name? Space, space, space,
The first letter of the last name.
space. Think computer science now. We're trying to manipulate this array. Space plus 1. You understand? Not the space, because the space is just the end of the first, it's like the end. But then plus 1, now you're at the beginning of what? The last name. You got me? Now how I determine where the last name is? Bam, no. So you understand what I'm saying? When you start programming, those are the things you're gonna be testing for and looking to try to, okay, let me read from here till I find a space. You got me? And then let me read from that space position plus 1 till null terminator. You got me? So you kind of getting a gist of, okay, this is what I need to do. This I need to go about doing it or whatever. You got it? Now, the thing is, when you start adding the name, the nickname, and the last name and the first name to another string, you're gonna have to add what at the end? No terminator. Remember? Because you might have a string that you're gonna be putting data in that's 100, but the name might be 20 characters. You know, first name, nickname, and last name. You don't want it to just print out all those spaces, because if you're gonna try to put it in a sentence or something, you don't want all them spaces over there. You want that null terminator to be right after the letter of the name of that first name. So stuff like that you'll have to think about. That's just to put that on your mind. All right. So let's look at this. When defining a character array for holding a C string, okay, be sure that the array is large enough for the null terminator. Now remember when we had the string literal, the string constant, we didn't have to worry about a null terminator because what? It was automatically placed. When I said name is equal to and whatever in double quotes, null terminator was all automatically added. But now, when we do something like this with char, company, and 12, all right, all of a sudden now, the value that can go in the company has to be only what? Can't be more than how many characters? 11 characters, because we need to say that last space for the what? Null terminator. You understand that? No, you got to keep in mind that null terminator. So it said the string input can be performed by using the CN object, all right? It allows the string to be entered, all right, that has no white spaces. You got that, right? So just the CN, remember from my 190, who all took my 193 class, remember we did the get line and then we did this, and just the CN, what's the difference in the two, right? Just the CN gonna read up until a white space. So if I tell you to input your whole name, all right, and use CN, not say CN, and input it, you use CN, you're gonna only input up to what? A blank space or a white space. But if you use the get line, CN, the name, then you'll read all the way up to what? To when you hit enter, okay? So, and what this is saying is with this CN, it allows the string to be entered that has no white space characters into the company array. If the user enter more than 11 characters, CN will write past the end of the array because it has no way of knowing the variable company has 12 elements. So it's going to write past the end of the array. When you try to output it, then it's going to get garbage because you won't have a null terminator. All right, so you got to watch that. So, but you can use the what? Get line and then CN and then tell it how many characters, force it to input so many characters. All right, so you'll be able to see that later. Look, well, it's here. So look, what happens here? It says the CN problem can be solved by using the CN, the CN's get line member function. So what happened? I defined a character of name line to be of 80 positions or 80 elements. Then I use the CN.get line, and then I force it to input 80 characters. You understand? Or like really the number that it can accept, 80 characters, but then the null terminator is added. So that forces it not to go what? Beyond the null terminator, okay? So you gotta watch. So what happens, CN will read 79 characters or until the user press the enter key, okay, whichever comes first, and then the CN will automatically append the null terminator, all right? So you see how those little things can be very, very, very tricky and very important when you write in code, especially when you're dealing with character data. You're like, man, Mr. West, I don't know, the letters, it just kind of, my mind, I'm getting confused because Man, all this little stuff matters. It really does matter. All right. Now, any questions? Questions before we move on? All right, let's look at this sample program. Looking at this sample program, all right. All right, this program displays a string stored in a character array. So all it did was allow a person to input a line of text and then output the line of text that they inputted, doing what? With the white space and everything. So if it had spaces in it, it didn't worry about it. It read what? All 79 characters, including the null terminator, and then outputted all that because the null terminator was automatically understood, appended. But then look what they did here. They printed each individual character. Everybody see that? They didn't just print the whole thing. They printed each individual character. Because if you look here, it says what? Well, first of all, let's see where a count should be equal to 0. See, count is equal to 0, right? So we have size equaling to 80. So when I read in my data, my max is 80 characters, right? But then the null terminator was automatically added to the end. So whatever I put in is going, even if I input characters more than 80, it's going to stop at 79 and put the null terminator. Everybody understand that? So now it's going to take line, which was inputted here. It's going to take those 79 characters, those 50 characters, those 10 characters, those 2 characters, that 1 character, whatever you typed in, right? When you hit enter, that's why it's going to put the null terminator, right? And what it'll do then, it'll say while line sub count starting at 0, because look in here, it incremented the count. So while count starting at 0, while line sub count, which is an array, line is an array, is not equal to what? No terminator. Not equal to the what? End of the line. You got me? So whether I type 10 characters, which would be the end of the line, whether I type 50 characters, which would be the end of the line, whether I type 2 characters, which would be the end of the line, it will process that many times until it hit what? That null terminator. Now, you can mess up with this, all right? I'll give you an example. Notice here we have what? Count plus plus, correct? If some way I have a program and it has multiple statements in here, and I added another count plus plus somewhere in this same area here, I could jump over what? My null terminator. Everybody understand what I'm saying? If say for instance, if I put in say four characters, BRCC, and then I had I had a count plus plus, then another count plus plus. The first time through is 0, right? It's gonna add 1, it's gonna be 1, right? It's gonna add another one, it's gonna be 2. All right, then it's gonna go back, it's gonna read, then it's gonna print out the second line sub 2, but then it's gonna add 1, it's gonna be 3, then it's gonna add 1, it's gonna be 4, and then it's gonna go back here, and then I'm past my null terminator. You understand what I'm saying? And all of a sudden now I'm in an infinite loop, or it's gonna try to find the end of the file or end of the line, and I could be either going into some other address on my computer, or till I find a null terminator in another location. You got what I'm saying? So you got to be wise and got to be careful as to what's going on within your logic. Okay, because if you want to process each individual object, make sure that you actually bumping up one at a time. All right, so that's what that logic will do. And this logic is basically a foundation of you inputting what? Your first and last name, correct? And then processing it from the beginning to the end to find out what? I want to go from the beginning to the end, but now inside it, I want to go from the beginning to a space. You understand? So it just is kind of like a foundation of that program we just talked about, putting your name in and doing whatever, right? All right. Any questions? Okay. Here we got C string library functions. All right. All right. So library functions for working with C string. All right. You can find the length of a string. All right. You can string cat, which concatenates a string. Concatenate means to join together, add together. Example, if I that's some good concatenation. Okay, I could just say Baton and Rouge. If I have a string that said Baton and a string that said Rouge, I could take Baton and put it and copy it, string copy it into a new string, or like the name school, and then I can string cat a space, and then I can string cat Rouge. And now I have one string that say Baton space Rouge. All right. So you can do that with the string length, string cat, and then the string copy. String copy allows you just to copy. All right, copy something from one string to the other. Then you got something called string end cat. String end cat allows you to concatenate so many characters. So rather than me concatenating all of the letters of my last name, I could just do the first 3 letters. So I could tell it 3. String in copy, same thing. Rather than copying a whole string, I could copy 2 characters out that string. All right. Then you got string compare. You can compare 2 strings to see if they're equal. All right. And then you got the string. This one, kind of like deal with pointers. What you can do, what it does, it allows you to search a string for a pattern. And then it actually puts you at that point, give you that pointer address where then you can print from that address on, because you had that pointer. All right. So you know, like how you print name, it's gonna print the entire name. If you use that string pointer, it points to, like, say maybe a middle part of that string, and then you could print that string from that point forward. All right. So and they give you the format. It tells like length is equal to string length name. So if I have a name that has 4 characters in it, it's gonna look at the length of it and store it into len, which would be an integer variable. All right. String cat, I could take this string cat first name, string 1, string 2. It takes the second string and concatenate it with the first string. Right? So it's just showing you how it should be copied. It copies the first string into the second string. String cat concatenates the second string into the first string. All right. So that's what they do. And the string end, this is where you put the number of characters that you want to concatenate, number of characters that you want to copy. All right. All right. Now, here the string length. It's just showing you the string length function. What they did, they created an array of characters. Let me move this one. I didn't move my other one. They have a string of characters, all right, called name, all right? The array size is 50, but I'm only putting in it what? Thomas Edison, right? What happens with this? It automatically does what? Put the null terminator, remember? So in this case, automatically put the null terminator. So now, if it automatically put the null terminator at the end of Edison, the length is from Thomas to, or T to N. So that's what? 1, 2, 3, 4, 5,
13.
6, 7, 8, 9, 10, 11, 12, 13, right? So that's gonna be the length, even though the array size is set to 50. Yes. Yeah, the array, yes. Once you allocate an array, you can't change it. But what that means is I can always go back and what? Name is equal to Thomas Edison. So what? I just made it longer, right? What I did, I assigned a new value to it that's longer, and the null terminator is placed at the end of it, right? As long as it don't go past the 50. You got what I'm saying? So no matter what, because you always can assign the values to it over and over and over and over, right? So, and then when you do the string length here, string length name. So what this argument does, it says, okay, we're gonna take name, we're gonna count these characters, and I'm gonna take the count that I have and store it into length. Okay, assign it to length. So the string length function, it accepts a pointer to the C string as an argument. Okay, it returns the length of the string, which is the number of characters up to, but not including the null terminator. So it just counts how many characters that is stored minus the null terminator. All right. The variable length will have a value integer, value 13. All right. So the variable, let's see, and it says, note, do not confuse the length of the string with the size. Like, remember you was talking about 50? Yeah, that's just the size of the allocated space. But the length, which means what's defined in that area at that time, is 13. That's the length. All right? So the only information being passed to string length is the beginning address of C string. It does not know where the array ends, right? So it looks for the null terminator to indicate the end of the string. So we're gonna count up until the end and say, oh, okay, I counted X, Y, Z, that's that. Even though the size is still 50, the array size. All right. So look, using this will do the same thing, using string length with the actual literal. So what? They actually typed in the value in here. And like I said, it's gonna return the same thing. All right. Because it's gonna do that minus the string literal. Now, looking at these string cat functions. All right. So look at this. The string cat function concatenates or appends, all right, one string to another. So if we're looking at this, we got string 1 is equal to hello, and that is a space after hello. All right. So hello space, right? That's the first string. The second string is equal to world, exclamation point. Then so if you notice, you got your array size. Yeah, you got your array sizes here. This is 13. Now, this is very important if they're gonna try to concatenate everything into string 1. Look at this. You have hello, which is what? 1, 2, 3, 4, 5, 6 characters, right? So that's 6 characters. So it says, see out string 1, it see out hello with the space. See out string 2, it outputted world, exclamation point, right? But if I do a string cat, string 1, string 2, which says take whatever is in string 2 and concatenate or join it or append it with string 1, then I have 1, 2, 3, 4, 5, 6, and then what? 7, 8, 9, 10, 11, 12. I had to make sure what? I had to leave enough space for the what? The what? No terminator. Because if I would have overwritten, if hello world would have been hello world, exclamation, exclamation, I would have overwritten the null terminator. And when I outputted my string 1, it would have given me garbage at the end because I'm referencing character or space after the array. You got me? Or position or spaces in the array that, well, no, it's beyond the array size. So I'm grabbing contiguous address spaces until I find a what? No terminator, right? So that's why you gotta watch. And you could try to put this in a program and run it and see what happens. And you're gonna see smiley faces or whatever and all this, or the system will start beeping because it's pulling in certain characters, whatnot. All right. So you gotta be careful, all right? Well, like I say, and this is a part of your program. When you create that new variable that you want to copy and concatenate everything in, you need to make sure it's large enough to what? To accept a last name, accept a large enough uh, uh, nickname, and accept a large enough first name. You got me? You can't say, well, I'm gonna just make everything 5. Because somebody might have a last name of what? Of 10. And then a first name of 7. You understand? And then the nickname might be 6 or 8. You done went beyond the size of what you done made your final rate to print out. You know, so you gotta watch. You gotta watch. Make sure you make it large enough because you're gonna always put the null terminator at the end, correct? All right. So this just showing you down here as of what actually happened. It allocated space for hello, which was 13. It allocated space for world exclamation point, which was 7. And then what happened when we did a string cat, it took world and added it from this point all the way to here. And then what? The null terminator was already here, right? At the end. All right. So that's what happened. So here we go. Now, this is just some examples as to how you can check or test in your program when you're trying to store data or concatenate data into or copy data into another string, whether or not you have enough space to do it. Look here. It says if size of string 1, right here. Remember that size of? So if your program you had input your full name. So, and right, you input your full name. But then you had well, input your nickname, correct? So they input their nickname. But then you can have a string called like final output, you know, final output. Now, final output, you can make it a certain size. But what you could say here is like, if size of final output is greater than full name, well, string length of full name plus the string length of nickname plus, let's say if you add the double quotes, the comma, and the whatever, plus 4, you know. And if it's larger, then you can go ahead on and execute it and do whatever you have to do with the conversions and whatever. If it's not, you can tell them, the input is too large. You understand? So that's what that would do. It allows you to check to see if you've allocated enough length so that the string manipulation can happen. All right. So that's all that is. They're showing you that you can do that to check to see if the string lengths are conducive or for being added together to make one string, and that one string is large enough. All right. So let's look at this again. It shows string copy function. All right. Unlike copying arrays, all right. Now, let me ask you this question. And it don't have to do with strings or nothing. If I wanted to copy an array of numbers into another array of numbers, or another array, a numeric array. If I have an int array, one array is of say 10 numbers, which will say is int 10, like say int num1 and then 10 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Then I have another array, num2, and I want to take the contents of num1 and put in num2. How would I do that? I want to copy num1 into num2. What would I have to do that? Anybody? Can I say num1 is equal to num2? I mean, num2 is equal to num1? Can't do that. Remember, we said that with pointers, because what? The name is the pointer address. Remember, when you're working with arrays, you have to individually copy with numbers each individual element into the other array. So you have to create a loop to go from 0 to less than 10, and then uh, number two sub x or 0 is equal to number 1 sub 0. Then going back through when x is 1, numbers 2 sub 1 is equal to number 1 sub 1, and then on and on. So now we're just copying everything from the first one into the second. That's how you would have to do arrays. But we know with name, I can say what? Well, not an array. You can't do it with an array, but with a string you can do it. But look at this. I would have to do copy. So here, unlike copying arrays, where you have to copy one element at a time, okay, usually using a for loop, which we just talked about, with string and string copy, all right, with the string copy function, you can use to copy one string into another, which we were talking about, string copy, string cat, etc. So in this example, name was set to be what? 20 characters. Then it says I wanted to string copy into name Albert Einstein. So as long as Albert Einstein is less than that size, -1, you know, and it'll take that name, well, it'll take it regardless, but you don't want to overwrite the null terminal. But it'll take that name and put into with Albert Einstein and put into name. All right. So it tells us the second argument of the string copy function is copied into the first argument. So what? The second argument is Albert Einstein. The first argument is name. All right. So it takes Albert Einstein and copies it into the variable name. So it'll take all of this, all of these letters all at one time and place in the name. But remember we said when we're dealing with a numeric array, we have to copy each individual element one at a time. Okay. So the second argument of a string copy, of the string copy function, is copied into the first argument, including the null terminator, okay? Hence copying Albert Einstein into the name array, right? So it copied Albert Einstein into the name array. And now what? The array size, well, the length, not the size. Now the length of that, of name is gonna be whatever Albert space Einstein is, the length of that, all right? So, if anything is already stored in the location reference, all right, in the first argument, it is overwritten, all right? So look at this. We have char, string 1 is 10, and it's equal to hello, all right? String 2 is equal to world, all right? But now, what happens here, we see out the first one, we see out hello, right? We see out the second one, it outputs world. But then we did a what? String copy. We said we want to copy the second argument into the first one. So we copying world into hello. So now what? Hello is the size of 10, but now we taking world and putting in hello. So now what? It's gonna put world, including the null terminator, and it's gonna print out the string 1, which is world exclamation point, and string 2, world exclamation point. So I just made them both equal the same. That's all I basically did. I copied one into the other. But it had to, the first one had to be large enough to accept the second one. Everybody got to remember that, right? It got to be large enough for it to accept it. Okay. Now, the string cat and the string in copy function. All right. So looking at these, and these are all the functions you're going to use to manipulate your program dealing with those, the name and your nickname, etc. It says, what? I need to move this. It says because the string cat, all right, and string copy functions can potentially overwrite the bounds of an array, which means what? It can go outside the boundary. Array can be 10, but it can print what? 15 characters beyond, or 1 character beyond, or 5 characters beyond. So it is possible to write unsafe code. Hence, could be writing virus software. You know what I'm saying? So writing software that'll start, and if you're writing low-level software, writing software that'll overwrite certain areas and what, therefore, making your computer not work in the manner that it should. All right. As an alternative, you should use the string ncat and the string ncopy wherever possible. And with Visual Studio, you will see a lot of times when I give this assignment, my students get warnings with this. And it's something you can do within your program. I forgot how to go about doing it to not get that warning. But what happens is you'll get a warning saying that, oh, you're using a string copy, whatever function is is a chance you could be overwriting, whatever. But it's just a warning. All right. The string in cat function works like the string cat, except that it takes a third argument specifying the maximum number of characters from the second string to append to the first. All right. So look, string in cat, I want to copy the string, whatever the string 2 into string 1, but I only want to take the first 10 characters. I don't want the entire string. Only accept the first 10 characters. All right. So that's simply what that is. Okay. Questions? Anybody have questions so far? I know it's a lot of information, a lot of little bitty. I got to do this. I got to be mindful of this. There's a lot of that. And you're like, oh, I got it. Till you get home and you start writing. It's like, man, what did you say about whatever? How is this whatever? It becomes very important. So, no questions. All right, because it is straightforward, but I'm telling you, it's like until you start doing it, it's like, oh, God, he said this. Oh, I gotta remember this. It's a lot of little stuff that you gotta remember. So, sample program. This sample program shows an example of calculating the maximum number of characters that can be appended in an array. All right. So we look. This pretty much is basically doing what we did before, where the max length, and then this minus this plus this. If it's larger, do it. If it's larger, then you can't do it. Otherwise, you can do it. So look here. So it's like it says int max character, all right, max charge. Okay. So I have an integer called max charge, but it's going to be used to calculate something. I have a charge string, a char array of string 1 of 17 characters, all right? And it's equal to welcome space. I have a char array called string 2, and it's equal to, of 18, that's equal to North Carolina, all right? Now, look what they did. This is max character. So it says max charge, okay, is equal to the size of string 1 minus the size of string 1. Well, the size of string 1, okay, which is what, 17, minus the string length of string 1 plus 1. All right. So what it did 17, okay, minus 8 plus 1, and it gave you 8. So what happens is they did max charge, okay, string cat, and this should be max charge. I don't know why I put this 2 here. So what happens is I found out how many characters that I can add without going over. You understand? That's what this little this expression did right here. I need to move that too. Yeah. Oh, it's time? Yeah. Oh, all right, man. Okay, let's finish this and we'll go. All right, I need to take this 2 off here. So what, because 2 ain't even nowhere here. So what happens is this is equal to 8. So it says string cat, string in cat, string 1 string 2, but the most I can put in is 8 characters. And that allowed me to put in whatever maximum from the beginning to whatever, without what going over. So these are some just little tricks that you can use to type. Like say if you were to write a program that you didn't want to bomb out by somebody coming in and typing, these are some of the validations that you can use. I don't try to put a lot of validations in my programs when I give them, because I want you to get the basic concept of it. But as a programmer, you always gonna have to learn how to validate, because you never want to write programs that, like I normally say, little kids can come in and press something and boom, it blows up or it don't work. All right. So validation is important, but I try to teach you trying to get it right first. And then, like I said, if you validate it, I don't have no problem with it. All right. So we'll continue on this on next class period, but work on your other assignments. And like I say, your other stuff is due next week. So take your time, like I said, but work on your assignment. All right, you can go if no questions. Anybody online? You got questions?
Professor Sylvester.
Yeah.
I have a question, but it's about the Linux class, so I was waiting till the end.
All right, we finished.
Okay.
Yeah, so everybody, if y'all don't have a question, yeah, you can go ahead on and go.
All right, hey, Professor Sylvester, I tried to register with those Linux Pro people twice.
Right.
And I think both ways I went about it the wrong way. The first time it asked me for an access code from my teacher. And when I put the promotion code, it said wrong code.
Right.
The second time I went and I tried to purchase the training for Linux Pro directly.
No. Let me Miss Shows, she's one of my former students. Miss Shows posted something. I don't know if you got it, but I think she did it through Canvas.
No, I'm the one who sent that email in Canvas.
Oh, to everybody about how to register?
Yeah, and all I did, I told them about my conversation with you.
Come in. You come in.
I told them what you had told me about it.
Right.
I sent you a copy.
Right, but look, let me show you what she posted.
Okay.
Yeah, she posted this, and I think she sent it to all of the students. You can still see my screen, huh?
Yes, sir. I see it, but I'm looking at the PowerPoint. Oh, okay.
Right. Yeah. Hold on. Let me get to the class.
Now I have the test out website open on my
Right, but let me show you. If I did I copy it. Oh no, this is the wrong class. This is what she said, and I told her, thank you. This. Did you see this? Ever see this?
No, I haven't seen that.
Right. This is what she posted. I guess I need to post it also, because I thought everybody had gotten it.
Maybe I missed it.
Right. Okay. And like I said, then you do that and then check out, and that's when it'll go in and ask you to do this at the end.
Does this show how much it costs?
Yeah, it was right here. Yeah, right here.
Okay, that's what I got when I tried to buy it directly.
Right, I know. But yeah, when you do that though, that code, you probably won't get that code. You know what I'm saying?
Yeah, I got you.
But yeah, this is what was sent, you know. And look, this is what she put in that price code.
Okay.
Yeah, student purchase, you know. And I think
so let me see the beginning so I can see.
Yeah, I can forward.
I click resources for students. Let me write that really quick.
Right. I could post it in Canvas though, in the announcement.
Okay. There was another student, by the way, who couldn't make class today because his hotspot ran out. So
yeah.
Cameron, his name is he asked me to tell you.
All right, what I'll
Cameron Ramazanu.
Okay. Yeah, what I'll do.
He's gonna email you.
Okay, and I'll post.
But he wanted to ask you if he had 2 weeks before paying for that Linux thing. or if he had to pay for it this week.
No, he got time. Yeah.
Okay,
But he still gonna have to get the work done. You know what I'm saying?
yeah,
Right.
okay.
Because
So
I don't know.
I'll let him know.
I'm not sure if they give you a trial period with the Linux. Because
Okay,
normally they would give you a trial period, but I don't know if they give you that in Linux. I know
okay. And the other thing I wanted to ask you was, I downloaded VirtualBox. I have the
yeah.
same VirtualBox you have, but I have to download a version of Linux to put on it. So,
No,
which
no,
one
no,
you think I should get? They're all free.
The virtual box should have everything in it.
Oh, the way maybe I'm not setting it up right, but it wants me to the VirtualBox can create a thing, but it has a choice of which Linux, but it doesn't put it on there. I have to have the Linux to put on there.
But see, I thought that's the purpose of the virtual box. The box itself is the Linux. You don't have to go and try to install anything on your computer because the box itself is the shell.
Yeah, the VirtualBox allows you to run several operating systems at once. So you could use it, for example, on a Linux and then put a Windows. Or in my case, I have a Windows and I want to put a Linux.
Right. But the virtual box, but the one I had, I thought I had the instructions where you could download the Ubuntu all at the same time and whatever. Unless
Okay. So would you recommend I use Ubuntu Linux?
It doesn't matter, but that's the one I did, and I'll probably you can use any one of them. Because if I give an assignment to make you do something in it, as long as you can perform what I asked, it should work. And Linux is Linux,
Yeah, I've had a long time desire to learn as much of Linux as I can.
Oh yeah.
And like I told you one time when you were advising me, when I saw those 14 computer classes for that 2-year application developer,
yeah, application
that completely seduced me to the BRCC because the titles of those classes were all things I've always wanted to learn.
Right.
Yeah. Yeah.
Okay.
Okay. All right. That's it. Thank you, sir.
All right. Now I'll post this in Canvas so that people can see it.
Okay.
All right.
Okay. Thank you.
You're welcome. Mr. Boudreaux, you had a question?